Okay, so here is another problem that we will build a model for. And these revenue problems are another type of problem that is so common. So this is another one that I would hope that you study and practice and do as many of them as you can, because they are all really similar once you get the hang of them. So here's an example of one of those. All right, so we have the price in dollars and the quantity sold obey this equation. So they're calling it the demand equation. And we know that P is equal to negative 1/3 X plus 100. Okay. And remember, P is going to be the price, and X is going to be the quantity or number sold. Okay, so for A, it says, let's find a model that expresses the revenue as a function of X. Okay, so revenue is always going to be, revenue is the amount of money you bring in. It's not your profit, but it's just the amount of money you bring in by selling something is called revenue. So in other words, revenue is the price times the quantity sold. Sometimes they tell you that, and sometimes they expect that you will know that, okay? The price times the quantity sold. So in other words, in our case, revenue is P times X, okay? But of course, we need to express this as a function of X. So we actually want the R of X. And so we do not want P in our equation, okay? But this is a pretty simple one because we already have P in terms of X. Right? So for P, we just need to substitute in negative 1/3 X plus 100. And then, of course, we still have this X. And now we do have our equation in terms of X. I think we're going to simplify that just a little bit by distributing the X so that we can see what type of function it is. So this would be negative 1/3 X squared plus 100X. All right, so our equation, as you can see, is a quadratic. It's going to be shaped like a parabola, and since it's a negative leading coefficient, it's going to be facing downwards, which of course I think makes sense because we would want to find the maximum revenue usually, right? We want to bring money in, right? So it's going to look something like this. Okay, so that is our equation. So let's circle that because I bet we're going to use that in other parts. Okay. B, it says, what is the domain of R? So this is an interesting question because it really brings the math part back into the word problem part, right? So in other words, does X have restrictions? So on a normal quadratic, of course, no, right? A quadratic could, all values of X could go in. There's no true restriction on this. However, in this real-world equation, it does not make sense to have X be negative, right? Because X is the quantity sold. You can't sell negative quantity of something. You have to sell, you could sell 0 of something, you could sell 10, you could sell 100, you could sell 1,000,000, I don't know, but you definitely can't sell negative. So we know that X has to be greater than or equal to 0. Right? Because X represents the quantity sold. Okay, but that's not the end of it, okay? Because we also know that the price, right? You would never sell something for less than $0, would you, right? Then you'd be paying someone to take it. So the price, P, also has to be greater than or equal to $0. I mean, you wouldn't want it to be 0, but I guess you could give it away for free, right? But that 0 there. So that's the price. So we need to set the price equation, negative 1/3 X plus 100. That we need to set greater than or equal to 0 as well. So in other words, negative 1/3 X greater than or equal to negative 100. And then multiply both sides by negative 1/3. So that's x. Remember, if you multiply or divide by a negative, the inequality flips. So that makes 300. So it also makes more sense. X has to be less than or equal to 300, because then you're going to get $0, right? And x has to be greater than 0 because we're not going to make a negative quantity of something. So the domain is between 0 and 300. Okay. All right. So now part C. What is the revenue if 100 units are sold? All right. So we are trying to find the revenue if 100 units are sold. And remember, X is the quantity. So we're looking just for the R of 100. So use your revenue equation. That's why I highlighted it in part A. So negative 1/3 100 squared plus 100 times 100. Okay, you're going to use your calculator, type that in. I already did somewhere, I know. I got, looks like 6,666 and 66 repeating cents. So I rounded that to 67 cents. A lot of sixes there, okay? So that's just the revenue if you sell 100. It's probably not the maximum, but it's just if you sell 100. Because in the next part, they say, what is the quantity X that maximizes the revenue? So we are looking for the maximum. Remember that we are, our equation is a quadratic. So the maximum right there is called the vertex. I'm sure you remember that. So to find the vertex, we can put this equation into our calculator, the one that is circled, and find the maximum. But you will have to change the window quite a bit if you do that to be able to find where the top of the graph is. Could be a little complicated to do that, although you know the domain, the x values are 0 to 300, but then you're guessing on the y values. So I like to use my h equals negative b over 2a whenever I can, right? So negative b over 2a. So let's find out. A is a number next to x squared, so that's negative 1/3. And b is the number next to x, so that's 100. So this would be negative 100 divided by 2 times negative 1/3. Okay, so multiply that out, and you are going to get 150. Okay, so 150 is the quantity for X. Okay, so in other words, that's all we need for part D, because it says, or the beginning of part D, what quantity X maximizes the revenue. So that's that 150 is the number that they should make. And then it says, what is the maximum revenue? So the second part, then you do the revenue of 150. So now you're putting in 150 for X. So 150 squared plus 100 times 150. And you're putting that in your calculator and you're getting 7,500. Okay, that's in dollars because it is the revenue. And notice it is higher than the 100, which makes sense because it's the maximum. Okay, now in part E, final part, it says, what price should the company charge to maximize the revenue? Well, I mean, there are a couple ways to do this, but I think the easiest way is to actually just go back to the price equation. You've got a price equation right there that's telling us if we put in the X. So we know 150 is the X, so then we'll find the price. So P equals negative 1/3 times 150 plus 100. Okay, and when you put that in, you get 50. Okay, so that's $50 because that's how much they should charge for each item. And if they charge, if they have 150 items times $50, they'll get the $7,500. Some of you might be thinking, I did it a different way. and you'd be right. You could also have put it in right here. Revenue equals price times quantity sold, right? Because you know the revenue is 7,500. You know the quantity is 150. So it's just 7,500 divided by 150. That'll give you the 50 as well. So that's a smart, super smart way to do it too. Okay.